Okay, hi everyone. So for today, we will continue with a topic that we have started from the last week regarding the digital or the device simulator express. And then we first use the circuit playground express, which is as you can see on the screen right now. Um, so now, before we start, I also want to demonstrate a certain functionality. This time, like how can we integrate the other sensors here, like for example, we have here the sound sensor, but for now it cannot be used, but we have here the temperature, the light sensor, um, also we have a motion sensor the motion sensor, so we can simulate the XYZ. And then I think that's the I think that's the three one where we can do some simulation. So this time I would like to demonstrate or to simulate how can I use the light sensor to control the value that will be or the that will change the behavior of this NeoPixel. So to do that, I'll revisit the library, and here we can click on the resources for the circuit playground, the Adaptive Secret Playground Express simulator. And when we go to the library tutorial, so here we can learn a lot about the CPA or the Circuit Playground Express. So we'll jump directly to the NeoPixel. So okay, so as you know, based on our previous activity, that we can use we use this one, the CP pixels dot brightness, to set the actual brightness of our device. And then here we also use this one to set a certain neopixel, and we set whatever color we want to display. So for this one, it will light up the red color. That's why you'll notice for the RGB value. For the red, we have 255, for the green 0, and the blue 0. So that's why here you'll see that it lights up as red. And then another example here, you can see it tries to light up the this one here. This is the pixel 1 0, and it lights up the red color, while the other one will light up the blue color. So basically that's the functions or um, method that we're gonna use in order to control the simulator. And aside from the NeoPixel, we'll also need to check the light sensor. So for the actual hardware, this is where we have it. And then here, to access the value of the light sensor, you just need to define or set CP dot light. So with our object CP, we called up the method or property light, and from that we can read whatever will be the value of our um, light sensor. So to demonstrate this one, you can see on my screen, here we already imported the library. So for next, I will also need to import. Okay, I think you can skip the time for now, but here I want to be able to get the value of the color, or I mean the value of the light, and I will assign it as a color or a value to the RGB tuples, or yeah, the three, the red, the blue, and the green values. So to do that, uh, initially I will set her a variable color, and then what I would want to do is I would like to get the value. So let's say CP dot light. So we could do it like this. So that means whatever the value of the light, will set it into the value of color. Or just to check, let's try to print it out. print color, okay, and then so that it will not um, consume much of the processing, or it will not force the application to run it so fast. I'll need to import sleep from time, import sleep, okay, and then here we'll print the color, and then we'll set um, delay, or yeah, we'll set it as some delay, let's say for 1 second for now. So the color will get the value of the light, and then it will print that color, and it will just delay 1 second before proceeding. I'll try to save that, and then let's run. So I'll need to move up a bit the output. So we will expect to see some output here. So you see, it prints the value 0 because currently the value is 0. If I'll try to move it, so since the value of the light now becomes 59, you will also notice that it now becomes 59. So what if you notice, I tried to slide it using the mouse, but you can also slide it gradually by using the left and the right arrows, so like this. So if you notice, I can gradually slide it to the left or to the right by just using the arrow. So that's why you can see that the there's an increase of 1 every time I press the right arrow, or a decrease of 1 also every time I press the left arrow. Or you can also hold it, um, press and hold, so that it will move up or move down fast. So that's how we get the value of the light sensor. Now the next thing I would like to do is I want to be able to control the light of the pixel, and then whatever the value of the light sensor will drive the LED or the NeoPixel. So to do that, we need to make some conversions, because if you notice that um, our light sensor is capable of reading a value from 0 up to 320. So that's the minimum and the maximum value that we can get from the light sensor. But also, if we look back on the NeoPixels, the minimum value we can assign to it is 0. So here it's explained here. Each member of the RGB tuple is set to a number between 0 to 255. So that means our um, NeoPixel is capable of accepting a value of 0 up to 255. So we need to sort of adjust the value, so that if I slide this to 0, the color that will be assigned to the NeoPixels will also be 0. While at the same time, when I put it into the maximum value of the light sensor, which is 320, it will convert it into 255. So because that's the maximum value that can be accepted by the NeoPixel method. And also, since the value of the RGB cannot be a decimal, so that means we need to convert it into an integer. So here's what we're going to do. So just to test this out, I'll need to remove this, and then this one also, since we'll no longer be using this. And here I need to call cp dot pixels, and let's use index 0. So that means we are referring to this one, and okay, and then we will assign the value of Um, so for now, we'll just put a color. For the red, we'll assign the color value. For the green, we can also assign it. And then for the blue, you can also reuse the value of color. But this time here, we cannot just set the value of color directly to the value of cp.light. So that means we need to do some sort of conversion in order to achieve the value of 255. So I cannot show you actually how I did it, but the formula that I will use is this one. So first I will use the end function. That means I will convert it into an integer, and then I will define 255, which is the maximum value can be accepted, times cp dot light. Okay, so that's the actual value from the mm, from our light sensor simulator. And then next, uh, we multiply, we also then divide it by 320. So how I did come up with this one, ba- uh, basically, if the if you see the value of the cp.light, let's say we put it into the maximum value of 320. So here, our formula here will become 255 times 320 divided by 320. So that means cp.light divided by 320 will become 1. And so the result will be that the value of color will become 255. And if we say that the value of int is, or I mean the light sensor is 0, so this part here, the 255, I mean this one will become 0, the CP light becomes 0, and then so 255 times 0, it will become 0, and will divide by 320, it will still become 0. Or even if I would say cp.light divided by 320, so 0 divided by 320, it will be 0, and then 255 times 0 will be 0. So that's how I try to achieve this one. So now, since we have now the formula, we will try to run this code, and let's check the output. Okay, so I'll try to move this a bit, then let's see if it's working. Okay, so now it works. So if I try to put it at the maximum value, so you'll notice that it lights up brightly. And if I try to move it like on the center, it also becomes dimmer, and eventually it dims until it it will turn off. So that's how we try to adjust its value. Now if I'll try to extend this, I can also just copy this one. I'll try to control all of them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I will control all the NeoPixel this time. So I'll change it 1, 2, 3, 4, 5, 6, 7, 8, 9. Save that, and then let's try to run it again. So okay, and then now if I'll try to move this, you'll notice that it's like since our code will start from 0 up to 9, so we'll notice that there's some delay. So that's why you'll notice that it's like it's trying to light it up one by one. But I think also it's because since it's just a simulator, so we could expect some delay. So okay, if I try to, okay, when I put it to 0, it also turns off one by one. Turn it on again. So but you'll notice that somehow it increases the value or the brightness, and also it decreases the brightness. So now I would like you to explore this one and try to test it on yourself, and then later I will send to you another video to demonstrate the activity that I will require you to do.